one. So this is also another opportunity. If it is in a face-to-face classroom, of course, there is some other advantages of it, but one major disadvantage, there is no recording. So for this case, it's all recorded. Therefore, you can read, you can listen, you can study again and again. Now, you can see that. Okay, that's the control systems course. I'm not going to talk about syllabus right now, since when I talk about syllabus, it's going to be tedious, yorucu. A lot of material we are going to discuss. But of course, we are going to do that. However, I would like to just give you brief introduction, and then probably next week we are going to concentrate on, since we have only 4 students in our classroom now. What's that one? What's going on here? Just a moment. Just a moment, please. I opened the program, which is not PDF. So now I'm going to come back to PDF program. In that case, there is no such stupid things. Come on. Really? Oh, it's still PDF. There's something wrong with this. Anyway, so this is the I sorted out. This is a PDF part. In a simple control system, we have a system that, if you cannot see my cursor, please let me know. That is our process. And this one is input, that one is output. Okay? And output divided by input is called gain. So that is a simple life. This is your life, this is your input, this is your output. For example, for our course, this is the course material. That is the input. You are studying the topic, and the output, your mark. But of course, it's not so simple. This might be, for example, the financial structure of a country. That might be a financial structure of the country, and that is the input. For example, let's say government is changing the rules, and then see the output, see the result. But that kind of system is not acceptable. It's not fully controlled system. Evet, burada bayağı bir şey var, problem var. Bakacağım sonra ona. Neden böyle? Çünkü PDF'de olmaması lazımdı böyle. Bir dakika, PPX açık. PDF'i açıyorum şimdi, bakalım ne olacak, düzelecek mi? I'm sorry. Yes, that's much better now. Now, this is actually, input is actually what you wish, and output what is the result in every control system. That is your wish, your desire, that is your output. Now we judge whether this output is good enough. Always you judge that one in every part of your life. If it is not, if that output is not satisfactory, is not the one you expect, what are you going to do? Yes, what we are going to do, what we do, is the subject of the control system. So control system is all about the the output should be obtained what you require, should be equal what you wish. The simple example, the NASA, for example, send a missile. You already know that one. Send a missile, and to obtain a device in your orbit, and to try to hit with that missile. So this is a control system. So if you cannot give the correct trajectory, if you cannot give the correct speed, and also the measures of the space where it is, if you cannot give it, you cannot hit it. So this is a simple control problem. But while the missile is moving, probably you can look at my face as well, you can see my hand, while missile is moving, and this is the target. So if you realize that target is also changing its position, it might be, for example, that might be a defense system, and that might be an aeroplane belong to enemy, so you would like to hit that one. So that control system is, you fire it, you give the sizes, then you calculate when this aeroplane reaches to that point, you are going to hit this one. So those equations reflect the control of the missile and hit the whatever the target would be. So there are a lot of control examples. However, there is always an actuator. Actuator means you, for example, for a robot arm, you are going to uh, connect for example, you have actuators here, you have actuators, and then this is a robot arm, and the actuator is changing the arm position. So it's an electric motor actually. And then at the end you obtain the output. For example, there is a device, and it's going to hand it and take it. So you are going to control those actuators, but when you realize that it's not touching this one, how could you correct this one? Open loop system, this is a typical open loop system which cannot do that. You can see that there is a controller. You are going to, when you complete the control course, you are going to learn about the controller. And also you already take electromechanical energy conversion course right now, so you know the electric machine's equations, not necessarily electric machine. It could be a heating system, it could be a pressure producing system, anything. But this is an actuator, and at the end there is a process, and the output divided input is called transfer function. If you have 3 blocks like this, or more than 3 blocks, more than 1 block, you remember, if you go back, that one is gain. There is only one output input relationship. But if you have a number of systems together, then is called transfer function. Output divided input. Don't forget that one. Transfer function. I continue. We are not happy about those open loop system. We are not happy about this open loop system. Since we just send a signal here or we just give the order here, at the end we obtain, for example, we require speed for a car 50 kilometer per hour. However, we say, all right, the gas we control, but it says 60 kilometer per hour. What are you going to do? Then you have to get a signal from there and this to see whether this output is exactly equal to this input, required input or not. I repeat the sentence. This open loop system is not a good control system. Output cannot be, of course you can measure it, but it cannot be compared with your input. However, if you look at that system, this is a closed loop feedback system. That this is required input and this is actual output, and the difference between you measure the speed, for example, and then of course sensors have got also a system. There are equations in it. There are equations in controller. There are equations in actuator. I'm sorry. And you can see that as a result of this one, you obtain a speed 60 kilometer per hour. However, you wish 50 kilometer per hour, or you wish, let's say 80 kilometer per hour, but this is 60 kilometer per hour. So when you measure this one and compare it with the input, 60, however, or 80 minus 50, 30 kilometer per hour is an error. The difference between your wish and the result. Then you change the controller. Your controller is defined and change the actuator and increase the speed. This is what is called closed loop feedback control system. You are going to deal with closed loop control feedback system. Don't forget that. Okay. This is a typical temperature control system. There is a resistance here. It's a furnace, so you are going to whatever you want to warm up or boil something. But this resistance, if you send a current in it, so heat is going to be produced, and that heat is going to, for example, there is a water in it, so increase the temperature of the water. But you also measure the water. That means this is actually your output. You give some energy here, heat, but that is your output. You get a temperature. You know the level. This is a digital control system. So this one is an analog controller. So it's converted to digital. And then there is, of course, and always an interface between those input-output device. Then you come to the controller. Your controller might be a microcontroller, microprocessor, or digital signal processor. So these kind of controllers, you programmed it, then send if the temperature is lower than what you require, which requirement is already hiding in it, it's compare it and say that, all right, I have to give further current to this resistance, further higher current to this resistance. When you increase the current, of course, more heat you produce, and the temperature of the water, for example, is going to increase, and then it's going to reach to that level. So when you send this level, this temperature is equal Geri gidiyorum. I come back. So the temperature here is equal what you wish. So error becomes 0. It's nice. So you actually reduce the current. Reduce the current here. And then, of course, you reduce the heat given inside the furnace. Then gradually the temperature level is getting down, then increase again. So this is a feedback control system where you keep the temperature constant. Let's say 90 degree or 50 degree, I don't know, depending upon the application. Not necessarily there must be a water in it. One thing I would like to ask you, since during distance teaching, I always talk. However, you may lose concentration. Therefore, time to time, I'm going to ask you questions. Time to time, I'm going to make that kind of, just a moment, that kind of manipulations. Just a moment, please. Yes, that's right. So if during the class, face-to-face teaching, of course, I time to time interrupt the course and I ask questions in order to keep the course participation alive. So that is the question now, and I just open up. Can you see the question?
Hujam, you removed the question fast. We couldn't respond.
Sorry, can you see now the question?
No, it's still the results only.
Well, you are going to say yes or no.
Yeah, but the question was removed so fast we couldn't actually read it.
I see. Just a moment. Again, I understand now. Yeah, it's up there. You can see that temperature measuring device is going. I
It's
see
showing
what you
right
mean.
now. Yeah.
Now, can you give vote now?
Yes.
Hamza, Hussein, I expect your votes as well. Halil has already given, Mohammed given, Ali Umut given. However, yeah, all right. Now, probably question is a little bit misleading. Of course, the answer is this one. That temperature measuring device is this one. So temperature measurement is output actually, not input. But since I wrote here temperature measuring device is giving information about the input, that's of course correct. It's giving information about the input. However, I add that one. It is an input device. Sorry, input. It should be an. All right. It's an input device. No, it's an output device. So actually the correct answer. This is an output device. Therefore, it's no. However, I understand that the question is a little bit misleading. Yanıltıcı. Okay. So that kind of games we are going to play, all right, during the course. Evet. Bakayım. Birisi bir şey yazdı.
It was by mistake, sorry.
Yes. All right. Unintentional. All right. Yes, I continue. This is a heating system, typical control system. There is another example. This drive control system is although the disk drive now is out of fashion. However, it's an interesting control problem. The information here is stored in a disk like this one. Şöyle imkanlarımız da var çocuklar. I don't know whether your lectures are using, for example, that's a kind of knowledge which is stored. So another knowledge is stored there, the outer part. Okay. Many knowledge, plenty of knowledge is stored already, but I assume that we have two knowledges. One of them is red, red saying that the color is red, for example, knowledge, and the blue one, the color is blue. But this head, just a moment, that head is on top of blue, therefore it's reading blue. But if you want to read the red knowledge, then you have to turn it delta theta, you have to turn it here and come to that point. You understand? So this arm, actually this arm is rotating, but it's only changing the position. So this is a position control system. Theta, the position of the arm, is defined by the control system. All right. There is an electric motor here. It's a kind of system like this. There is an electric motor here, and this an arm here. This is the arm, and the head magnetic tape reading material is there. So the electric motor will be rotated like this, and then when you rotate it, so this arm is going to rotate. You understand? So this actually we have seen on top of this one. I don't know whether you understand or not. So this point is that point, top of it. This arm is this arm, okay? So it's rotating. So actually you are controlling the electric machine here. There is an electric machine there. This one is electric machine. And it's also rotating like this. Okay. So while you are changing the electric machine, that disk head arm is going to come to that position from theta 1 to theta 2, and then you read the knowledge stored in disk, which is following the red line. Probably you understand that one. So this is a position control system, that one. That is also another position control system. You can see that all the information is stored in your computer, and the electric motor is actually moving. The system is in this direction or in that direction. So this is a position linear actuation, linear direction. It's called translational direction. So the one which here was rotational, that one is this one is linear. But the point is this: for example, that point here, this point there, should be precisely equal to this point. So when you move the inner part moving and coming to this one, of course there is a for example, this is a machine tool application. There might be a cutting knife, and then cutting, for example, wood, or cutting steel, making some holes and things like that, whatever the application would be. But this is a position control system again. In that case, for this case, you are involving delta theta rotation. For this case, however, we are involving delta x. Linear motion. This is x direction. Okay. These are some examples, and this is a through the road hybrid electric vehicle example. That electric motor, sorry, that's right. That electric motor is driven and rotating the wheels. For example, for low speed applications, you don't need to run internal combustion engine, and also you don't have to use the fuel. You have already stored energy in your battery. Sorry, you remind me if I've forgotten to use the cursor. I repeat, electric motor here, which is driven by power electronics. Next term you are going to take power electronics course, and you are going to learn those equations, those systems. and the battery is providing electricity, and the power electronics is processing it and control the speed. Then they run the wheels with, for example, 20 kilometer per hour. When you reach 30 kilometer per hour, internal combustion engine runs, and then increase the speed. In the meantime, for example, when you pull your leg from the gas pedal, of course, this system is rotating, and that one becomes generator and produce electricity, and then this electricity is stored in the battery. Did you understand that one? Mohammed says yes. I'm glad if you understand. You see, uh, English is not our native language. Therefore, those who cannot understand Turkish, I avoid mentioning anything in Turkish. Okay, since I don't know Arabic either. Therefore, we have to continue in English. But I know the concentration time to time becomes reduced while you are listening. Listening is more difficult than explaining things. While your lecturer is explaining things, he's active, but you are in passive and you are listening. Therefore, you have to participate that one. Okay, so you always think that what's going on here, what kind of system is this, and if you do not understand, or if you have anything any point missing, or you would like to make a contribution, you just open your microphone and say something. You may interrupt me, you understand? Don't worry. So in classroom, probably you are going to raise hand. You can raise your hands as well if you want, but I don't mind if you say something during my understanding and things like this. I don't know how many students is going to be registered, but for the time being, we have only, bakayım kaç kişiyiz? We have only 5 students in our classroom. Okay. This is another example. Is a steering problem. Is there anyone who would like to explain what's going on here? We just assume that. Is there anyone who wish to explain it? It's a control problem. There's a curvature, so turning right. The vehicle is turning right. If you do not change the steering wheel, you are not. If you do not change the steering wheel, then it's going to go out of the road. It's obvious. So what you do by your eyes, you look at the road while you are driving the car. You look at the road and you see that there is a curvature over there, and then you change the steering angle, and then you obtain the correct direction. Always your eyes is sending a signal and getting an information, and then your brain is evaluating it, and you always continue the right pattern. Okay, but if it is a robot, if that one is a robot car, what are you going to do? We have robot car in our lab. Probably you have seen that Linea project. I was the leader of that project, but couple of years back we prepared a car for controlled without a driver. What you need in order to have a robot car? Yes, Mohammed.
We will need a sensor, a visual sensor, or a radar that will
That's
see the
right.
the
The first thing is this. However, the car cannot rotate their steering wheel. So first of all, you need a motor, electric motor, to rotate the steering wheel. While you change the steering wheel by your hand, however, for that kind of system, you have to provide an electric motor which is going to rotate the steering wheel. This is the first point. But as you pointed out, that you need sorry, you need a radar here. You need a radar here, or laser radar we used is called LiDAR, laser radar together, and they send the laser signals and get the signals back. So you while you are getting those signals, you have to rotate your steering wheel. But not only that one, the brake also should be by your leg. You use gas pedal and brake. For brake, we replaced an electric motor here, linear actuator actually, as if a human leg is pushing the brake pedal. So this electric motor is also connected to computer. The steering wheel electric motor is also connected to computer, and the gas. So the gas pedal, we haven't used actuator. We actually in a vehicle. Ali Umut Terzi bir şey yazmış. Okuyacağım şimdi. We need upgrade our in a way how humans do real life, adding adding radars acting like eyes, adding some initial motors acting like our arms, etc. Good. Well, uh, since you probably don't know my background, I next week I also will start with my background as well. Yes, that's right. In order to reduce the speed, you are going to control the Hamza says. In order to control the speed, you also use brake actuator, which is controlled by computer. In order to accelerate that one, we have add an electronic controller inside the vehicle to change the position of the throttle. You know that throttle is something which actually produce air and also the petroleum mixture. So when you increase the petroleum mixture, then the throttle is sending more petroleum and then vehicle accelerates. So torque getting up. This is what internal combustion engine vehicle is operating anyway. So you have three, one of them is steering angle, the other one is brake, the other one is gas. Should be controlled. This is what we have done first. Then you need information about the environment. Radar. There are radars now in sophisticated. Probably you don't know. We have very sophisticated autonomous vehicle project right now is going on. I don't know whether you know that one or not. In our lab, probably you have seen that simulator in our building. So in our lab, we have laser radar, we have radar, we have also camera. Camera is very important. Those intelligent cameras are developed. So normal, first of all, I have to say that human is the most sophisticated robot. So your eyes is also evaluating all the knowledge and then sending signals to your brain, and your brain is decided. You see, you are although the vehicle is keeping the distance between the front car, but you always look at the road position, the road surface and things like this while you are driving your car. So whatever we act, we try to reach the human abilities. For that case, however, we have improved the system. For example, the camera itself is very clever. Then it understands all the vehicles, differentiate whether there is a cat or dog in front of your car or human. So, and also decision is taken, which one is going to be hit, human or the dog. If you have no choice, of course you are going to hit the dog. So it's a very sophisticated software business as well, but there are a lot of very sophisticated hardware inside those, for those robocars or autonomous cars. Then of course the control system operates and then keeps the vehicle safe in the road. This is one of the most sophisticated control problem as well. Still, when it's more difficult than sea transportation. It's even more difficult than aeroplanes, for example. The difficult problem for aeroplanes is landing, and also the leaving the airplane. So particularly landing is important. But while it's moving on top, in air, so it's not very difficult. However, here you always control the road condition. You have always control the whether there is something in front of you. We also control the driver as well. If you put a camera inside the vehicle, driver if driver becomes there are a lot of accident occurs while drivers are sleeping. They are lazy, they are tired, and also feel bad. Then the camera itself looking at the eyes of the driver and then decides that that driver is hopeless, so actually takes the lead and take the car very safe place and stop there. So this kind of actions occurring. Okay, so this is what autonomous driving is all about. This is another interesting example, block diagram of engineering organizational system. I know you are tired, but I'm going to, at the end of this slide, I'm going to cut the course to prepare myself for the next week, since we have, but don't leave. I always take the what we call it attendance list. So I record who is attending my course. Of course, 70% attendance is required. I have some tolerance about it. However, 70% is according to the rules. So block diagram of an engineering organizational system. So the required product, the managerial board is saying something about this. They say we require this one. However, when the product is actually produced, then this value is coming to the management side and it compares the quality standards and the price, whether these are satisfactory or not. If these are satisfactory, then required product value is satisfied, and then there is no need to change. However, for starting point, then first research and development is done, prototype, preliminary design, and those preliminary design inside the lab. Then, of course, some experimental, some tests conducted. Of course, for your lab prototype, the first one you build, you manufacture is not satisfactory. Then you measure it. You say, all right, there is something wrong with it. This part should be restored. Then you run, you change your design, you produce another prototype. Then at the end, after several tests, you realize that your prototype is good for lab conditions. Then product design and drafting phase, and also fabrication and assembling line is prepared, and also as a result of that one, another quality control department measure the results, and then this is the product. This product, for example, is let's say a camera, okay, conventional camera. But when the cell phones are developed, they have very good professional cameras. Then you realize that you send that product knowledge, and you compare it with the required value of the market. You realize that you have to also provide a cell phone. So you cancel the producing. Kodak, for example, used to make cameras like that. Then you you start cell phone production. For that one, you conduct research development. A lot of engineers come together, scientists, and then develop a prototype. Then in your lab, you control your prototype, you make some tests, you obtain some bad results, you then restore it, you make better, and at the end you decide that it's very nice, then you produce it and sell it. Okay, now for example, you are selling iPhone, let's say 6, but then your managerial board thinks that I don't know which one is the top now, iPhone 7 is necessary. So, all right, then another research, and then another product. This is what product organizational product development system structure, which is a control system. You can see that there are feedbacks here. I know you are tired. I am tired too. It's my first course. We are going to come to the mathematical part of it. I'm not going to start that part, but I'm going to leave that course note in Blackboard so you can see before coming the course. Okay. Ali Umut, sen 3. sınıfta mısın? Are you in the 3rd or next year in the 4th year? There's a course called Science, Technology, and Ethics. I teach that course, so it's going to be a very enjoyable course. Science, Technology, and Ethics. Of course, particularly the development of the artificial intelligence has risen the ethical problems. For example, data collecting. You see, everybody is now collecting knowledge about information about the people. In order to when you approach to market, for example, then you can see your cell phone that this store is selling this store is selling that, and things like this. They know that you are now approaching that marketplace, the mall, for example, and then they send you some invitation letters. So that should be like this, but this is what happening. All right, next year there's an ethical course. I just don't leave. I'm just going to take Muhammed Abdul Wahid, Halil Hatim, Muhammed Ahmet, Hüseyin Mahir, Hüseyin Al, okuyamadım. I couldn't read the part of it. Hamza Muhammed İbrahim, Ali Umut Terzi, Ahmet Faiz Haydar. You all attended. So you are going to be the first week course attendance list. Thank you for listening. Is there any question you are going to ask? Okay. Okay. Okay. Bye-bye then. Bye-bye. Take care of yourself. Thank you. Thank you. Same to you.